So you have seen, you can see the screen, eh?
Yes.
Okay, just check
Yeah,
that.
we're all good to go.
Okay, okay.
Very useful looking Keith Costle there. So good. You all set, Tony?
Yep, I'm fine.
Good, good. Well, I checked out the ICAO and the EASA websites before coming online today, and I can, you know, I see the traffic levels are around 50% of 2019 at the same time overall. But that's it's obviously this cargo traffic is the same, if not a little bit more, but it's obviously passenger traffic that's down. There's no surprise there, and we seem to be seeing the start of a second wave here in the UK, and there've been fluctuations across Europe. Now, of course, viruses being more comfortable in winter settings, they're seem to be more transmissible in winter settings. The fear is that we're going to start to see an upturn, given that unfortunately the population as a whole seems to be growing rather tired of social distancing and let's say best practice, conforming to best practice avoidance procedures. So I must admit I fear the worst for our industry, because the consequence will be more quarantine procedures, and I mean it's been the death of very little business traffic. I'd imagine. I imagine the traffic that we're seeing has been leisure, you know, they're borne out by the spikes in COVID in the UK, Ireland. Well, in UK and Ireland, have been basically surrounding people coming back from holidays, which of course is what happens at this time of year. So
I really don't think that business travel will be ever the same again, because COVID has driven us down the online meeting concept, and companies, businesses will be looking at things quite closely on what their expenditure is, and to travel, you know, from you know, one country to another continent just for a business meeting, which used to be a factor, and it used to be that there was business travel, so it was business class. Now that in many cases disappeared a few years ago, so that you know, persons then traveled economy rather than business travel. And then the COVID has now changed that whole scenario once again, right? And then more and more companies were looking at their expenditure and saying, well, we can do most of our meetings online because we've been doing it for the last few months and it works.
I think as well, with the UK government imposing new and changing rules all of the time on different destinations, people are also concerned that they might book a business trip, go out, have the meeting, and then whilst they're actually over there, find that they're now in a country which is deemed to be a high risk. So when they come back, they have to isolate for 2 weeks. So they then say, well, as you say, we've been doing the Zoom meetings. Is it really necessary? Can we actually have this meeting face to face in a virtual environment?
Yeah, well, that's correct, you know, and but when you look at it, it's not just you know, you say from from a UK perspective, but that's the same everywhere. It's global. This is a global issue, you know. So countries are looking at it on a day-by-day basis and making decisions accordingly. Some countries have already said there will be no international travel until 2021. You know, very bold statement to make, but some countries have actually said that, you know, but they may change their mind next week. Who knows, eh? So it's very fluid. The scenario at the moment is very fluid. But when it comes to business travel, I don't see this ever returning back to the same level as it was before.
Yes, and that with
economics.
very serious knock-on consequences. So, so it remains to be seen what's going to happen there. But I think there will. I think I agree with you, Keith. I think there'll be a partial. I think that you're right in the trend you identify. I think there'll be a partial recovery because I think the underlying reasons, you know, in face-to-face contact, you know, does give competitive advantage, and that's why people will ultimately travel, because it's it is a personal business.
Well, one of the things that one always does say, in opposition to what I've just said, there's one element is that you can't replace the look in someone's eye. Hmm?
No, indeed. So, Keith, it is once again 2 o'clock, and the time is upon us. This week is week 15. As I said before, I can't believe the momentum we've got behind this program, but it's been very as a presenter, I found it very interesting and thought-provoking. The process of putting together and reviewing the materials. It just goes to show you, doesn't matter how much you think you know, there's always something new you can learn. And of course, working with yourself and Tony, I'm not short of material in terms of new stuff. So thank you very much to both of you gentlemen for that. So we're on week 15 now, and we're looking at installation this week, and installation and commissioning. And so I know Keith has been working very hard on his presentation. We're going to, I won't keep talking. I'll let Keith get on with it. It's going to be followed by a question and answer session as usual. So look, use the question button on your computer. If you have any questions, I'll try and get through as many of them as possible live on the webinar. And if we're not able to answer them, regardless, we will post answers to all of the questions on our website, tmstrainingsolutions.com, where you can see the answers to your questions and any other questions, as well as the seminars from weeks 1 to 14, along with any materials that we've also posted on our website. So without any further ado, Keith, I'd like to hand over to you, and we'll talk again in 30 minutes or so. Okay, Keith, over to you.
Yes, good afternoon, everybody. Good morning, good evening, wherever you are in the world. Welcome to webinar 15. I have to apologize, that webinar 15 should have been last week, but as previously explained, that there were IT issues associated external to us, to the organization, and we weren't able to proceed. So it was better to postpone it and carry on and do it this week. So welcome to webinar 15. And what we're going to be talking about is installation, commissioning and compliance. And we have our moderator, Robert, has you've just been talking, but of course we then have our specialist team, and which hopefully can answer all the questions that may well come up. But the key issue is that this is an awareness webinar of installation, commissioning, compliance. It is not a training course. It is an awareness. Then that we're going to discuss certain things. And what I just want to remind everybody, that when we're looking at the AGL, the airfield ground lighting, and the life cycle and the competency needs associated with the knowledge, the skill, etc., to be able to work with airfield ground lighting, there are 4 blocks. The 4 blocks you'll see in the blue section on this area, and the equipment itself that we're talking about. We need tools and equipment, and etc. We need to have documentation, very, very important, certainly in the installation phase, to ensure that that we have the correct documentation clearly spelt out how we're going to do it, what we're going to do, what tools we're going to use, and how we're going to demonstrate compliance, etc. But of course, we need to know what to do. So the fourth block is the competent personnel. So that exists regardless of whether it's design, whether it's maintenance, or whether it's installation. So showing that again, but I asked the question to you, can you demonstrate your competency and being able to justify your competency to be able to install, if you're an installation contractor, to be able to commission what you have installed and to demonstrate that the equipment that you have just installed and commissioned is compliant with the standards. And we have to have certainly a wide knowledge. Yes, it's an electrical system. It's an electrical system in airfield ground lighting. But when we're talking about electrical, we're talking power engineering, we're talking the distribution engineering and control systems engineering. We also have to have an understanding that, hey, you know, we install these things out in the open on a big airfield. So they have to be mechanically strong, structure, etc. So we need to have an element of an understanding that these fixtures, these light fixtures that we put in the field, need to be structurally strong, but those that stick above the ground, which are elevated lights, need to be frangible, breakable, just in case an aircraft does have an incident and come off the runway or taxiway. If it hits a light fixture, elevated light fixture, the light fixture breaks and not the aircraft. When we're installing also, we have to install our equipment onto bases, etc., whether it's an elevated light or whether it's an inset, an in-pavement light. So we have to have an understanding of civil engineering because it's a very important part. And we're going to have a little discussion about that. So the electrical, the mechanical, and the civil side. But ultimately, photometry, we've got to demonstrate that the light gives a light. So just to re-emphasize, this is just an awareness webinar. It is not a training course. So let us look at those engineering technologies, the civil, mechanical, and electrical engineering technologies, and understand this electrical system is different from conventional electrical circuits. When we've all done our electrical engineering, we're talking building technology, we're talking constant voltage. And then I come along and we say, okay, you can now work on the airfield because you're an electrician. Yes, but it's different. Why is it different? It's constant current. And constant current is fundamentally different. Why? It's a constant current. It's a series circuit, not a parallel circuit. It's not a series parallel circuit. It's a series circuit. All the equipment that we put out there have to be watertight. And we all know that clearly water and electrics don't mix very well. And in most of the world, a standard connector system is used to connect the different parts of the cabling, the system that we put together at installation. Now, what is really important, having that basic understanding, is who actually does this work? That people again, you know, the competency side. Because, you know, it's very difficult commercially when you're bidding for an installation and commissioning job on an airfield, then there are two parts. There is the engineering submission of how you're going to do it, but there's the commercial submission. And certainly in many times, and some of the experiences, and I'm going to show you this, that the person with the lowest price is not necessarily the best guys or girls for the job. And I'm going to show you why during this discussion. We've also got to have an understanding that there are differences in considering elevated lights, that is a stick above the ground, and the inset, or shall we say, in-pavement lights that we put into the pavement. And this webinar, we will concentrate on really discussing the in-pavement, the inset light installations, and also what tools, what equipment, and what the processes the documentation we need to do that. So this is the emphasis of what we're going to be talking about this week. So let's remind ourselves what an AGL electrical series circuit is. It's a power supply. We get a constant voltage power supply to the substation or volt. Then we have to convert that to a constant current output to go out to the field. And in the field, we have a single cable, series cable, all the way around the lighting circuit, back to the volt or the substation, to where the constant current regulator is. And so let's have a look at that. But let's just remind ourselves again what an elevated light is and what an inset light is. An elevated light sticks above the ground like approach lights. And this is a picture of approach lights, you know, on masts. And these masts are breakable, they're frangible in accordance with the Aerodrome Design Manual Part 6, ICAO's Aerodrome Design Manual Part 6, tested, approved in accordance with that. So there are various manufacturers that will provide those mounting equipments. When we look at this picture, they are lights that we install in pavement. Fundamentally different, eh? Fundamentally different. And so the installation criteria is different as well. So that's what we're going to talk about. They have to be structurally strong. So let's have a look at both the civil, the mechanical, and the electrical side of an AGL circuit. But electrically, what is in there? We're going to concentrate not on the control system today. We're not going to talk about the substation and the CCR. We're going to talk about the cabling that goes out, this primary circuit, series circuit cabling, and the aspects associated, which I've really highlighted there with this dotted line in grey. So we'll look at the civil, mechanical, electrical, and the photometrics associated with that part of installing and commissioning AGL. So let's put our AGL into little blocks. What's physically there, you know? Well, we've already mentioned in the vault, in the substation, we've got the CCR, the lightning arresters, and perhaps an output disconnecting device. That is not part of our discussion today. Not part of our discussion today. But we have the primary cable, which may well be screened or unscreened. We have the primary connectors. That is those common, widely, internationally used connectors. It could be a plug and socket, but it also could be a through joint, you know, an inline splice. We have isolating transformers, and within the primary circuit is the primary winding of the isolating transformer, whereby on the secondary side, on the secondary circuit, we have the secondary winding of the isolating transformer. They are separate circuits, basically. The primary and the secondary circuit are electrically separated, only joined together by the series isolating transformer, which is a one-to-one series current transformer. To get the power from the transformer out to the light fixture, we have the secondary circuit, the secondary cable, which could be 2 cores or a 2-core cable. And then again, we have to connect this cable to the transformer and to the light fixture. So we have secondary cable connectors. And again, it could be a plug and socket, mostly is a plug and socket, but it could be a through joint, but mostly plug and socket. And in this case, instead of being a single core plug and socket, as is the primary, it is a 2-core plug and socket. It's a plug and socket for 2 single cores or a plug and socket for a 2-core cable. There are differences. And of course, then the light fixture itself, which could be an elevator light, could be an inset light. But we are going to talk about inset lights really today. The other element is the other things. Now, 2 of the other things is basically an earthing network. An earthing network is for bonding purposes. So we've got a common voltage reference of 0 volts all the way around the circuit. And there is also a counterpoise earthing network. A counterpoise earthing network which is for lightning protection. There are fundamental differences, and we will just briefly look at that. And so that's what we're talking about. So let's firstly start with how not to install. Like I mentioned at the beginning, lowest price is not necessarily your best choice. And here is a project, and this is in South America, so I'm not going to tell you where, but this is what we experienced when we arrived on site, and went, oh dear, you know, look at this. And then look at how they've installed the inset lights. So the inset lights are sitting actually proud of the surface, which this mountain base is proud of the pavement surface. And if we look at it from a side elevation, this is what we see just here. So I don't think that is a very suitable installation. And fundamentally, if we look at it from this direction, that is what we observe. So pretty clear that is how not to do it. The also other element is when we install our light fixtures, which have to be installed into a base unit of some description, then we have to glue it into the pavement, and we have to use some kind of resin. If you do not use the correct type of resin, then this happens, and this is foreign object debris, foreign FOD. So if you get foreign object debris, there's likelihood you're going to get foreign object damage. Remember Concorde in Paris, when a piece of FOD fell off an aircraft, and then Concorde followed and then that FOD then damaged the aircraft and crashed, and all people were killed. When we look at the elevated lights, let's have a look at the elevated lights. Here, look, this is an element of civil engineering gone wrong. So here, look, is a guidance sign. This has been pushed over by jet blast, and it's because the base unit was not structurally, civil engineering-wise, was not structurally appropriate and strong enough. I mean, not just did the base move in the earth, it actually pulled out. So it was so thin, or the lack of depth was so thin that when the fixture bolt went into the concrete, it got pulled out, as shown here. Likewise, on an elevated light, here we've got the elevated light, and here is a breakable, frangible coupling onto a base plate. That coupling is supposed to break if something hits the light. In this particular case, not so. What happened? This PVC, thin-walled PVC pipe had been used. So when the light was hit, the PVC pipe broke, not the frangible coupling. Fundamental errors in installation. Likewise, here we've got an elevated runway edge light, and our runway edge light is seen it's a bi-directional light. It's seen in two directions, but the light itself has toe-in, So when we measure, that is what we're measuring on from a photometric viewpoint. If you misalign it, as it's shown in here, clearly, whoops, sorry about that, clearly, then the lights are pointing in that direction. So if the lights are pointing in those directions rather than that direction, parallel with the center line of the runway, then clearly we're not going to get the correct photometric output. Fundamental errors in installation, potentially because you've chosen an installation contractor with little experience, pretty no competence at all, and probably got the job at the lowest price. So let's have a look at the documentation side. If you prepare well, if you define exactly how you're going to do the work and how you're going to demonstrate compliance and what tools you're going to use, then you are partway to executing a good project. And so firstly, here is a method statement for the civil, mechanical and electrical element of a project. And this was a taxiway project, and this is in Istanbul, sorry, not Istanbul, in Kabul, in Afghanistan. And likewise, on the electrical side and the control side, then because it is an electrical system, AGL is an electrical system, then there is an electrical method statement. And then finally, there is a document for site acceptance. How we're going to demonstrate and take records of how we're going to demonstrate compliance, and that what we have installed civilly, mechanically, and electrically, and controls if it's part of the project, then we need to demonstrate it. This is Kabul in Afghanistan, and the project was Japanese main contractor with a colleague, Perfect Airport Solutions of Singapore, as the AGL specialist installation and commissioning contractor. So just to expand that a little bit, I put those three documents there, front page documents, but extracted out of the civil, mechanical and electrical method statement, just one paragraph on the scope, setting it out, the excavation, cable trenching, the manholes, that is the transformer bits, and of course in installing the lighting system. And on the electrical side, I selected out one of the paragraphs, the equipment that we're going to be using, or they used on site, which is a whole range of equipment and what is being used to be able to install a taxiway project. And finally, an extraction out of the document we use for the site acceptance, which says how we're going to demonstrate in this particular case, in this project, substation equipment, how the taxiway lights were going to be demonstrated and what we did and what measurements we took, etc., and the control side, and the details of the actual measurements and demonstration of compliances in a set of annexes. So moving on to then the civil side. Let's have a look at the civil side, starting there. The real civil side is the fact is, and we're concentrating now on inset lights rather than elevated lights. The same scenario exists for elevated lights, but let's concentrate on inset lights. Let's have a look at the loading capacity, because in civil, it's construction, the operation, and the maintenance phases we have to take into consideration. But of course, the loading capacity is a very important, because our aircraft from the cockpit is going to land or run over the pavement, which is also going to run over our light fixtures. So we need to have an understanding of the loading capacity on the pavement and how it affects our AGL. But also from a operation and maintenance phase about rubber removal. So that's another factor. You know, we get rubber, and we've talked about that in other webinars. So moving on to the loading capacity, and I'll just concentrate on this one only, not on the other three, but loading capacity. There is the ACN PCN factor. So we as electricians have to have an understanding about this civil requirement, because the civils do an excellent job to actually install a pavement structurally strong enough to withstand aircraft loads. So the loads from the aircraft, which are dynamic load, horizontal shear and a turning moment, then is the aircraft classification. It has a number. So types of aircraft will have an aircraft classification number. And the pavement itself will have a pavement classification number. So it's a classification system. So the ACN, PCN, we need to understand that, because as I said earlier, you know, when we come along, we've got a beautiful pavement that the civils have done a job, and we're electricians, we come along and for an inset light, cut a hole in it, weakening the structure. So let's have a little discussion about that, eh? But how do we install inset lights? Two ways. One, through deep bases. Two, through shallow bases. in the US and in the FAA related or US military airfields, or those areas associated with FAA standards, then will adopt deep bases. The rest of the world, most of us will use shallow bases. So when we're looking at deep bases, there are two types. There's load bearing and non-load bearing. Load bearing, obviously in the pavement, that's called an L868. And there is a non-load bearing for those areas where the aircraft do not run over, then there's an L867. But when we look at the L868, there are two types. There's a solid type, which looks a bit like that, and there is a sectionalized type. Now the solid is for concrete, rigid pavement, where the sectionalized is for flexible pavement, asphalt. Because pavement, concrete pavement, is installed in slabs, big slabs, with expansion joints in between, where the asphalt is done in layers. And therefore, to install a deep base in concrete, then you have to be working with the civils very, very early, because you need to get it correct at the top, at the surface. And whereby in the flexible, on the sectionalized type, then we can actually, we work with the civils during the work, and one layer is put down and a base unit, a bottom section of a base unit is put in. We put a cover over, then the next layer goes in, and we have to core down, we take the cover off, we put a sectional in, bolt it in, put a cover on, and the next layer is put on, and it goes up to the surface that way. And so there is different types. When it comes to shallow base, we come along after the civils have done their job. Because what we do, having known what we're going and made arrangements how we're going to get the cable out to the light fixture, whether we're going to be in ducting within a sublayer, or whether we're going to cut a saw cut in the surface afterwards, those kind of things will have to be determined, including whether it's going to be side entry or bottom entry. But then we core a hole. So we've got this wonderful pavement that the civils have done a smashing job meeting the ACN, PCN factor, and we come along and cut a hole in it. And when we cut a hole in it, we're going to put a foreign body in, a foreign body. And this foreign body is aluminium alloy, mostly. And we're going to put it into either concrete or to asphalt, a different body. So we are going to have to glue it in there somehow. So we're going to use resin. So we'll have a little talk about resin in a moment. So that's the criteria that we have to consider. So we have to have this civil engineering understanding knowledge associated with it. So the grout itself, now many types of grout out there in the market, and different locations around the world, people use different suppliers, different types of grout. But remember, the grout is the fixing of an AGL light base into a pavement, be it concrete, be it asphalt. And so the grout itself must adhere to differing surfaces, right? Aluminium alloy, concrete, asphalt, for example. And it must be structurally strong. So we have to make sure that whatever grout is used is going to hold that light base in the pavement when all these aircraft loads of dynamic load, horizontal shear and turning moment are placed upon that light fixture. And it must be able to accommodate with deformations of the surface, because what happens in horizontal shear, you get the wave effect associated, which means that the pavement itself will move with the Young's modulus of elasticity element and then return back to its original state. If you go past its Young's modulus of elasticity, it will stay deformed. And so we've got to be able to move with the pavement and return back. So the grout must accommodate for that. And also we need to have some electrical properties associated with the grout. So the whole subject of grouting is really, really important. And what is interesting in grouting is that is the type that we use. Now, if you use, for example, an epoxy-based grout unit, compound, it's a two-part mix. And the interesting part, you choose the grout according to what your job. And so you get a hardener and you get a resin. And you put all the hardener into all the resin and mix it correctly. In some of the other grouts, you can have more hardener or less hardener, dependent upon location, temperature, etc. So, and that creates a risk factor. So from my perspective, I would always choose an epoxy-based resin to remove any risk factor of the lack of experience of the personnel. That's my view, right? And that's what I always promote. And so moving on, here's a little diagram look, and I've taken this look from an installation training course that we do, and the installation training course is done in cooperation with Possiel, the Netherlands, and Possiel are experts in top coats and installing AGL in the civil engineering. They produce the resins themselves, so they have an epoxy-based resin and different types with different applications, etc. And here is just a picture of a diagram. It's purely a diagram, just for explanation purposes. We've cored a hole. We've put a base unit into that hole, and having aligned it straight and level and according to the surface. And then we may adopt different kinds of application or resin applications, depending on where we are, what pavement it is, etc., etc. So there is a complete range of options. So this is done in practical terms on a training course. But if it's like, I've shown this look with concrete pavement, if it's concrete, it's done in slabs, then we have expansion joints. So we have to having decided how we're going to get our secondary cable out to the lighting fixture, if we do it in for example, across a joint, we have to accommodate for that joint. Here I've shown it with a saw cut, and we need to establish we can't just put our cable straight across a joint. Why? Because when the joint moves, then it would break the cable. So we have to accommodate for that. So this is just a diagrammatic example. And when you do a training course, an actual practical AGL training course, installation training course, then we do these kind of things. Moving on, when we core a hole, we have equipment to core a hole, and we have to have some knowledge of what drill bit, core, coring bit that we use. Here is some pictures of coring bits, and these little things, the shape of this and what's on the surface of this cutting edge this is diamonds, diamonds, and they're so very, very hard. But the key issue is you've got to put these coring bits onto some kind of drilling jig. So there is mobile drilling jigs, and there are drill carts. And this is these are three pictures from Brunei. Actually, it was done in Brunei, in East Malaysia, on the island of Borneo. And so Brunei is a sultanate of Brunei, the Brunei airport. And this is a project. But the interesting thing about this is this was a mobile drilling rig. It's an electrical powered mobile drilling rig. But it's also, if you do not, once you've worked out exactly where you're going to core the hole, and you use the correct diameter drill, coring bit, etc. If you do not fix it to the ground as a portable unit, or put big weights on it, like is shown here, when you turn the motor, the core will stay steady, and the whole assembly will twist. So you have to have this understanding of how to use the equipment. Likewise, if you've got a drill cart, and these are pictured and supplied to me by Possil, and they, in fact, have their own design of drill carts, and so they are self-leveling, etc. However, they do also utilize electrical for the mobile and or hydraulic units, portable mobile units, you know, for overseas work. But very, very expert in the installation of AGL and the tools themselves, plus the grouting. So, you know, it's a package. So when we do our installation course, we will do installation courses in cooperation with Possil. But let's go back a stage now, and we've now shown this picture again, you know, diagrammatic picture, and then we've caught a hole. We're now going to put our base unit in, but then it's hanging in space. If we want it straight and level, transversely and longitudinally, and at the correct height, according to the surface of the pavement, then we've got to hang it in space. So we need to have some kind of jig to hang it in space, and then we will align it, and then we can put the resin in to glue the base unit into the pavement at the correct height, at the correct orientation. Just an example. Now, most contractors will make their own installation jigs. Usually a nice T-piece. Look, a 3-point T-piece is ideal, because then you can always 3 points when you're aligning something is very, very good. It's like installing a pappy. A 3-legged pappy is far, far more user-friendly to align and install. So is an installation jig like that. Then going on to the electrical side. On the electrical side, we've got the primary cable, the connectors, the isolating transformers, the secondary cable, and here's a list, and you can have a look at this afterwards. I'm not going to go down this whole list of its 6mm squares XLPE, which is cross-linked polyethylene type C. Without going into all the detail, but these are the things that we have to look at it from an electrical viewpoint. Are you competent? Do you have knowledge of all these elements as an installation contractor? And going back to the fact is that we've got to demonstrate compliance as well. So if you are installed a cable, a series cable, which is capable of carrying 5,000 volts at 6.6 amps, you've got to check its insulation resistance and continuity resistance. And so we check the installation resistance using a 5,000 volt insulation resistance tester, commonly called the mega test. And but if you've got a brand new circuit, now this is an IKO Aerodrome Design Manual Part 5 definition and need, is that for a brand new circuit, that is cable, connectors, transformers, then on the primary circuit, once only, we test it at 10,000 volts, and once only. Thereafter, 5,000 volts to demonstrate. Now, we've got to define what the insulation resistance value is after installation, before handover, as part of the site acceptance. And the nominal, I'm not saying you have to do this, but the nominal figure is around 2 gigohms that we expect to have insulation resistance on a brand new circuit. IKO define a minimum acceptable level, and it's calculated according to 2 microamps for every transformer and 1 microamp for every 100 meters of this primary cable. So that's the criteria. But we define that in our documentation. We need to be really clear right at the beginning. So that's the AGL electrical primary side. Looking at the cables themselves for the primary side, 4 types, type A, B, C, and fly C. Most around the world is type C, XLPE, cross-linked polyethylene. and it can be a screen cable, which is mostly the rest of the world outside the US and some of the other areas, and they use unscreened cable. But again, it has to be tested, and the criteria for testing is no different. But we need to also not just to do a test on the insulation resistance for water tightness, its safety, etc., and that it's all been installed correctly. Then we also need to do a continuity check to make sure that we haven't got a high resistance joint out in the field. So on average, a type C XLPE single core primary cable will have approximately a little over 3 ohms per kilometer continuity resistance. So in fact, some manufacturers define it exactly. One particular quality manufacturer, then it's 3.11 ohms per kilometer. Moving on, the connectors themselves, it's an international standard, as I mentioned earlier. Now that's international standard. Then there are different types, primary and secondary connectors, as I mentioned earlier. There's different classes. One is for molded onto the cable, and the other is for the field. And then there's all the different styles, plug, socket, etc. So screen cable, unscreen cable. So a whole range. So we have to select. You get them as a kit, and I would recommend you get them as a kit because there are manufacturing tolerances depending in different manufacturers. So be very, very careful. And two types of two basic types of connectors, those that get filled with resin and those that get filled with silicone grease. And that is part of the water tightness, not just the manufacturer and the sizes and the insulation, etc., but also how we secure and make the internals of the connector, once put together, watertight. The isolating transformers themselves, they also come with molded. They come with long leads, and some of the issues associated with installation is that we misuse. Who of you out there, and be honest to yourself, not to me or anyone else, but to yourself, how would you carry an isolating transformer? I bet a lot of you carry them by the leads. Then you are potentially damaging the water tightness there. They are tested normally at 3 times the operating voltage under power. That means if it's a 5,000 volts tested, designed for 5,000 volts, then they're tested at 15,000 volts under power, underwater. So we know that they're good when they leave. They're very good when they leave the factory. It's the installation contractor that creates a problem, hence competency. Here's some pictures of projects, because we've also got to set out and do transformer pits. And here, look, is a picture. This is again from that taxiway project in Kabul in Afghanistan. And here's some ducting where the cables are in, and with transformer pits. And some can be manufactured on site, others have to be lifted in depending on the size and the requirement. The thing is, this is called a pit and duct system. Now, cables are designed also to be directly buried. So there are airports, and many, if you go to the Netherlands, for example, and many airports, they'll directly bury the cables. But they're designed for that. But the pit and the duct system, sadly, it becomes part of the airfield drainage system by default. So invariably, these things get full of water. So we go to a transformer pit out on site, and you take the lid off, and it's full of water. Hence, we have to be watertight. Now let's go on to the earthing network. The earthing network itself, there is an earthing network, and generally speaking, the ohmic value is 10 ohms to earth, or whatever your national standard is. And we have to ensure that we have a common earthing reference all the way around, bare copper wire, and we earth them with earth rods. No requirement to say how many earth rods, as long as you can achieve and demonstrate your national standard or an international generic standard of 10 ohms to earth. Then moving on to the counterpoise earthing network. Now this is an issue about associated where it's for lightning protection. It's a bigger cable. It could be a matrix of cables, like on a grid system, joined together. But it's there to protect the cable in the event of a lightning strike, which could induce a voltage into our cabling, which could then go back into our substation and blow up our CCRs and the electronics in the CCRs. So we protect it so that should this happen, then hopefully this will discharge the lightning to earth, and will discharge it to earth through earth rods. And with a counterpoise earthing network, there we are defined. We must have earth rods in the field, and they shall be internationally no greater than 300 meters apart. Now, some nations have their own criteria for that, so just to beware. So a counterpoise earthing network is for lightning protection, but an earthing network is for bonding purposes. And the cabling and where we install the cabling is different. Now we're going to demonstrate compliance. So we've got to switch it on. We're now going to switch it on. We've checked everything. So, and we know that lights have different values, intensity values. Runway lights have a nominal 5 steps, and taxiways have a nominal 3 steps. Not always exclusively that. They can be different depending on our nations. But here is a list out of the a list which is demonstrated out of the IEC technical specification, and defining a 5 steps and 3 steps. And these are the current values. But please note, these are current values, which is at the lower end of the intensity percentage levels defined by ICAO, whereby ICAO in Annex 14 say 100%, 30%, 10%, 1%, 3% and 1%, 5 steps. These values, now these percentages are at the higher end, but the higher end at maximum is 6.6 amps, but there will be different currents for the higher tolerance than the lower tolerance. And these are the lower tolerance elements. Not many people know that, but we have to understand that and demonstrate that, which then leads us on to the mechanical side. And the mechanical side is to make sure that we are firmly installing both elevator lights and inset lights. And this is inset lights using a torque wrench, an electronic torque wrench. Now, the electronic torque wrench is ideal because we can program in the light fixture. It will tell us what torque setting it's got to be. It will monitor the torque setting. We have to do it correctly, so it will know that an 8-inch fitting has got 2 bolts or nuts, and a 12-inch fitting has got 6, and we have to do them all before it allows us to move on. Plus, we need to know exactly where it is. So RFID tagging is ideal for this, and it's accurate, as it knows exactly it's that light fixture, and it gets recorded accordingly. Some people say, oh, we can use GPS, but actually GPS, if you've got lights pretty close, such as a runway center line and a lead off or a lead on light, then GPS is potentially not as accurate. So RFID tagging is, for me, is the most proactive. And the beauty about the electronic torque wrench is you can prove that you did the job correctly. You know, so if something did happen and a bolt did come loose, you can say, well, I did it. I've done the electronic torque wrench, we have the records, and it proves, because you cannot finish the job until you've done it correctly. And this is really a safeguard operationally, but safeguard to you as the engineer. Oh, mechanical, we have to understand this. It's a mechanical engineering. And then coming back to probably the last thing is demonstrating compliance, doing a photometric test. Now, a photometric test, we're checking our lights in accordance with the ISO cantilever diagram in Annex 14, but also if you want to know the percentages of light output, etc., etc., we go to the Aerodrome Design Manual, Part 4, Chapter 17. And here is a picture of the mobile photometric tool MARMS, and it's being used here at Birmingham International Airport in the UK. But that's a picture that is shown on the back page of Chapter 17 in the Aerodrome Design Manual, Part 4. And we are demonstrating compliance. And those records then are kept at commissioning and therefore can then be moved on to the maintenance people so they can check exactly what the photometric output is at final installation and commissioning, and then thereafter it can keep records. So it's ideal for that aspect. And so just to remind you, this is also, if we use the photometric tool together with an asset management system, then through the cloud, as we call it, then these records are immediate and can be demonstrated to the regulator, not just to the airport, but to the regulator for compliance. So I just want to say to you, remember, serviceability is compliance. Unserviceability is non-compliance. It's as simple as that. And remember, you cannot manage which you do not measure. It's as simple and straightforward as that. So everyone, today, that's kind of the end, and I'm very happy to receive Q&As. And I know you've been asking questions, so Robert, maybe you could come back in, and Tony and Paul, you could join us, eh?
Okay, well, thank you very much, Keith. That was absolutely super presentation. Very informative, very thought-provoking as well, because when you talk about competence, it's a constant, it's a perpetual work, really. And listening to your presentation today, you realise how much you don't know and how much you need to know. And the only way you find out more and learn more is to educate yourself and to get more experience. And so yeah, very thought-provoking, very interesting.
I think one of the things, Robert, is to remember that an installation course is primarily a practical course. So you have to do the job. Anybody who's mixed resin will know that it's not as straightforward as just turning something in a bucket. Eh? There's more to it. If you have to apply resin, whether it's to a saw cut and into a base unit, whether you have to plug and socket together. You put a plug and socket together, if you get it wrong, then you're going to get leakage, or you're going to get a short to earth. So,
yes.
So an installation course is primarily a practical course. Mm-hmm.
Yes, I recall, because as you know, we do a lot of talk management. In fact, talk management was how I got into the industry, because of following an incident where a light came out of the runway and got impaled in the fuselage of an airliner. In looking at various incidents involving lights coming out of runways, I've come across instances where shallow bases, the entire base has come out of the runway, not just the bolts coming undone or breaking, the entire base came out of the runway.
Yeah, something you have
and
to
the reason,
remember, Robert, when
yes,
when you look at that element, every force has an equal and opposite reaction. We tend to not understand the mechanics of life. Eh? Each force has an equal and opposite reaction. Now, if you get the depth of your core incorrect, and you have either too little or too much resin underneath, then there is an element there with this force of equal and opposite reaction, then a base can be dislodged.
Yeah, in this particular instance, it turned out that the base had been installed in extremely cold weather, so cold that the resin didn't harden and no additive had been applied. and that was and so the consequence was that the light came, the whole base came out of the runway.
Yeah, yes.
But without records to show which other bases have been installed at the same time, of course, you had no ability to remediate and address the issue on that particular runway. So,
and if you have not got the correct method statement and site acceptance criteria defined, then when you look back at that phase, then you cannot actually, you know, identify and exactly what you're saying. You cannot justify that the work you did is correct unless you've got the correct documentation.
you can't manage what you don't measure, as you said a moment ago. So yes. So without any further ado, I'd like to introduce our panel. Tony, of course, fellow of the Royal Institute, inventor of the PAPI, and hugely knowledgeable expert in the field of all aspects of aviation and airfield lighting, and in particular, Paul Smith, who has been, I've been fortunate enough to have been a colleague with for now, it's over 12 years we've been working together.
Indeed.
Yes, yes, and so Paul has been to more airports probably than you know, than anybody else on the team, and gives you a huge
probably more airports than some pilots.
Yeah. So gets a huge understanding of because it gives you a benefit. You get the benefit of seeing so many airports and so many installations, because of course we're at the end of the chain. And just to make an interesting point, because we are at the end of the chain, the last thing they do before the flight check is the photometric check. Very often the project has been delayed because of various issues and weather and personnel, and so the concrete goes down late, the electricals go in late, the lights are the last thing to go in, and so very much we see the end of the project, the most stressed point of it, where all the time has been concertinaed to the magical opening of that runway or taxiway. And so this is the most high, you know, it's highly critical, the performance of the airfield lighting, but it's often squeezed into the most implausible timescale. And I do feel sorry for the guys we're working with, because, you know, we only have one standard. It has to be serviceable, but these guys are often working to impossible timescales, because with all the best will in the world, their project plan has been concertinaed into a fraction of the time that they were originally scheduled to do. And we've seen it firsthand, haven't we, Paul?
We certainly have, and I've been to more than one site where that has actually happened. We've been called in to do a photometric test, and basically they're saying to us, the runway opens tomorrow. And I'm saying, well, how do you know that this is going to be a good installation and that you've got time to make any remedial actions necessary? And the answer quite often comes back, well, you know, we'll deal with that if and when the situation arises.
Yeah. And unfortunately, any flaws often are just left to the operators of the runway at that point, who then have to maintain in serviceable condition something that wasn't serviceable when it was installed. But that's another story. So let us carry on then with your questions. First of all, gentlemen, I've got a first question here. During installation, what consideration should be given to maintenance? Following on from my last comment, actually. For example, torque management systems rely on RFID tagging because GPS is not sufficiently accurate. What is the best way of installing RFID tags? Keith?
Well, you know, when you're looking at, obviously it's a location, you know, but very simple, it really is very simple. Coring a small hole, you know, just slightly greater than the tag itself, popping the tag in, and then filling it with the appropriate resin, and then of course giving it its ID. And it's a very simple, straightforward job, but hugely rewarding when it comes both at commissioning and during maintenance.
Keith, the other important thing to think about as well is not just randomly drilling a hole somewhere around the circumference of the light, but to be consistent about what you do. So always, for example, choose to put the tag on the northern edge of the light, or
Correct.
the eastern edge of the light, however the orientation of the runway suits that particular thing. Then the guys that are coming along to do the maintenance operations at a later stage, we've got a good idea where the RFID tag is and where to start looking for it with the scanner.
Correct.
A question I think for you, thank you, Keith. A question I think for you, Tony. The question is, if I have AGL responsibilities at an airfield that has no precision approach aids but intends to enhance its services, are there any particular issues that I should raise during the design phases of the project?
Yeah, I think so. I think what Keith's been talking about today are the civils, mechanicals, and the electricals. You know, I go back a stage and say, at the project definition phase, have you got a proper understanding of the operational requirements? What services are you trying to support with these visual aids? And I'll just give you one cautionary tale. It goes back a good 20 years. One country in Europe, not a particularly large country, where the government played a large part in deciding what equipment should be put into airfields. They decided to replace all their runway edge lighting. The manufacturers came along with their latest technologies, which were nice bi-directional fittings, complying with Annex 14 completely. But then all hell was let loose when it was realized that it was a non-precision, possibly category 1 sort of environment in a lot of cases. So the non-precision guys, who actually their procedure is largely governed by flying to a beacon near the aerodrome and then flying a visual circuit with reference to the runway, found there was no omnidirectional component in these runway edge lights as there had been in the earlier design. And so they were severely disabled and not being able to fly a visual circuit, which was crucial. So I think at that level particularly, remember there is a requirement. If you look at the simple approach lighting systems in Annex 14, we concentrate a lot on the precision category 1, 2 and 3 lighting and takeoffs in low visibility. But ICAO does address simpler lighting systems for operations where the non-visual aids are perhaps quite sparse. And I just say with that, I noticed another day I was looking on Facebook at some nice approaches to difficult runways. I think it's probably in Nepal, I'm not sure. This runway on a sort of plateau with mountains very adjacent all the way around, saying one of the most difficult runways in the world. Yes, I could see that was so. The touchdown aiming mark was very close to the threshold, but there was no PAPI there. And I say, for goodness sake, why not? Because that would sort quite a lot of problems out if you put a PAPI in there.
Yes, thank you. So, yeah, there's the voice of experience and a very, very important point there. Yeah, if you do have any more questions on that subject, whoever asked that question, please, you know who to ask. Tony's your man. So, Tony, I think again here, is there any need for in-service testing of AGL if my airfield does not support non-visual approach procedures?
I think the answer to that is definitely yes. I mean, the requirement, the totality of it will be quite a lot less, I guess. In many cases, you won't have a runway center line, for example. You may have very little inset lighting, but what you have got is there for a purpose. I come back to the non-precision approaches. They use day and night, that lighting, and it does need to be up to specification. the values that are given in Annex 14 are there for a good reason. And so just because you're not a major international airport doesn't, I believe, reduce in any way the importance of regular maintenance. And to do that, as Keith keeps saying, you can't manage what you can't measure. So you've got to go out there and measure the performance. Because as you say, Robert, we're at the end of the whole chain. What really matters is what comes out of that aperture, what comes out of the light that comes out.
Yeah.
That's important. That's it true of all classes of approach and landing and takeoff operation.
As an unfortunate fact of aviation, whilst it is the safest form of transport there is, when there are fatal accidents, 60% of those occur on final approach and landing, so to make it by far the most dangerous part of the flight. And of that 60%, over 90% occur in low visibility conditions, when lighting is the key determinant factor. So airfield lighting is absolutely critical. And Paul, I know that you do a lot of, we do a lot of in-service testing of in-service omni and medium intensity lighting, don't we, Paul?
We do indeed, yes. And I think I'm of the opinion that, you know, Annex 14 is it's a very large document, and there's a lot of things that are in there, but it's a standard. You should adhere to all of the items that are in there. You shouldn't be able to pick and choose whether or not, just because you don't have non-visual approaches, you shouldn't be able to decide for yourself that you don't want to do the relevant testing to make sure that you're compliant.
One of the aspects to think is Annex 14, you know, ICAO really are dealing with high intensity lighting. They do not deal with medium and low intensity lighting as such in terms of the photometric output. You're quite correct, you know. There are many airports that operate on medium intensity lighting, low intensity lighting. It doesn't mean to say that they should not perform according to those candela outputs. You know, ICAO is a guideline for high intensity lighting, and we turn it down according to the, you know, nighttime, daytime, dusk, and RVR conditions. But quite correctly, Paul, you know, it's medium and low intensity is equally important.
Airports are it's incumbent upon an airport to operate safely, and in today's age you need to be able to demonstrate you're operating safely. Your airfield lighting system, those lights are specified to perform at a certain level, and as we know from Keith's previous lectures, the only way you know if a light is performing to its required level in terms of beam intensity and beam orientation is by measuring it. So whatever the airfield, if you have a lighting system there, I think it's incumbent upon you to perform in-field testing and to be able to demonstrate that it is routinely functional as specified.
Well, I think one of the things, though, Robert, is that you know inherently we have concentrated on runway-related lighting. You know, that includes approach. You know, really the runway-related lighting. But of course, taxiway lighting is equally as important, especially in today's of surface movement guidance and the traffic density that we had, you know, prior to COVID. But you know, the other lighting systems, which generally do not get mentioned so much, such as guidance signs. You know, they are an AGL lighting fixture. So
I'll pick you up on that.
Runway and you know, etc. But all of them are important, eh?
Yeah, I would say that that's something that, again, a little story. The importance of the taxiway lighting and the signage. I was talking one day to one of my former test pilots who had then changed career and was flying for an airline in the holiday business. And I said, what is the most stressful part of your operations generally? and he said, because we go to all sorts of airports on Greek islands and all over the world, perhaps only go there once or twice ever, the most stressful thing is the taxi in after you've landed, because the probability that you can get on an active runway and have a collision or finish up embarrassingly in a wrong place where it's difficult to turn the airplane round perhaps because you've gone to the wrong place. Those aids are absolutely crucial in his mind, to know his situational awareness, knowing where he is and that it can get from the runway to the terminal area in an expeditious, safe manner.
It's a very good point, Tony, because I spent some time living and working out of Lanzarote, one of the Canary Islands, the Spanish islands, off the coast of Africa, off the coast of Morocco. And interesting, in Arrecife, the Lanzarote International Airport, then just because it's holiday traffic, so really relevant to what you're saying, under the IENA regulations in Lanzarote, then every single aircraft, when landing, has to have a follow me vehicle to take it to the parking position, because there are huge numbers of aircraft at times, landing and or taxiing.
That's good. Just for the audience, we'll carry on with the questions and answers a few more minutes. But for the audience, our next week's presentation is on the topic of guidance signs. We've talked about the lighting, we've talked about PAPIs in particular, but we're going to be talking about guidance signs because it's absolutely critical. One of the key things for a pilot when they land at a new airport is actually getting from the runway to the stand, and signage and of course associated taxiway lighting is absolutely vital because if you're not familiar with an airport, there is surprisingly little standardization across the world. Although the basic guidance is standard, the actual application of those standards from the pilot's perspective can be quite challenging. So we'll be talking about signage, and Keith will be obviously making that presentation with the support of Tony and Paul Smith on the panel again. So I have another question here from Wayne Rolfe, who's asked Keith, hi Keith, what are your thoughts on centerline ducting rather than secondary ducts from the pits?
Well, that's an interesting thing because, when you have a center line, then, and I'm presuming you are talking about a runway center line rather than a taxiway center line. And when we talk about a runway center line, then there are different ways to get the secondary cabling from the transformer pit to the light fixture. So the routing is very important because quite often you may well have ducting, and when you have the ducting, you may well go from the transformer pit. Remember, transformer pits, generally speaking, if we are, because they are associated really with runway edge lighting. So runway edge lighting are 60 meter spacing, so transformer pits tend to be 60 meter spacing. Yet when we add a center line on a runway, they become 30 meter spacing for Cat 2 and 15 meter spacing nominally for Cat 3. And therefore you have to decide what your routing is from a transformer pit. So the transformer pit, you could go perpendicular out to the center line and then go left and right, to the 30 meters that way and 30 meters that way. So you can cover 3 light sections by doing that. Or you can go directly, at an angle across. So that has to be done at the design stage, not at the installation. It has to be, as what Tony said earlier, when you're looking at an installation, you go back a stage to the project definition stage, okay? And what is actually defined. And then is it practicable to do so? And so there's that element of it. So, to answer that question offhand straight away is difficult because ducting in a pavement, you have to be more accurate of where your cable is when you come to core your hole, right? if you're going to then install the cabling afterwards and decide to do the Circult method, then of course you are deteriorating the pavement surface. Although you are using the special resins to ensure to return the pavement as near as practicable to the previous ACM-PCN factor, then you are actually deteriorating. So there is different viewpoints on this, but it's definitely back to the project definition stage rather than the installation stage. So if Jane, you want to talk to me, you can call me, you know my number, and I'll go through all the scenarios with you.
And I have Karan has asked us a very specific question. What should be the depth of core cut for a 12-inch shallow base, and what is the acceptable gap between base and asphalt pavement?
Then number one, you've got to liaise with the supplier, the manufacturer of the base unit, because you've got to know the size of a 12-inch base unit, because nowadays, when you're looking about depth, there are different bases which have different depths. And then depending upon the resin that you decide to use, then there will be a minimum and a maximum width and depth underneath according to the resins that you use. As I said, you know, I personally recommend to use epoxy-based resin, and to take the risk factor, some of the risk factor out of the installation equation. So for Karen, what I'm saying to you out there is that you need to liaise with both the manufacturer, your supplier of the base unit, and with the resin manufacturer who you choose to have the resin.
Thank you, Keith. Next one from Mohammed, who I believe is who's watching us from Iran. Dear Keith, where can I find torque standards for lights?
From the manufacturer.
Yeah. It's very interesting. If you look at Annex 14 and do a word search on the word torque, it doesn't come up once. Manufacturers are the main source. The most authoritative document in terms of standards relating to torque is EB 83, Engineering Brief 83, published by the FAA, which is quite an interesting document. But so I recommend you read that if you want to learn more about the subject. But ultimately, I believe a torque management system, I would do, wouldn't I, is the best way of managing your bolts, both in terms of scheduled inspection to monitor that the bolts or the nuts are remaining in situ at the intervals and at the torque prescribed by the manufacturer, and then also to aid you in your system of preventative maintenance, because it should enable you, a good torque management system should enable you to identify any hot spots where the bolts are becoming loose, so you can increase your inspection standard.
Well, one of the other elements, Robert, is, you know, when it comes to the competency of the people that are actually doing the job, you know, then the tools are there, as you quite rightly say, to aid the person who is doing the actual job. And one of the aspects about the electronic torque and the torque management system is the fact that you remove the risk factor away from getting it wrong. If you use a mechanical torque wrench, as I have experienced, then when I said, right, you would demonstrate on site, demonstrate what you're going to do to replace an inset light fitting, and I watched the process, coming right to the end, and they torque down, and because they get the mechanical torque wrench out of the wagon, and I then say, okay, very good. What torque setting? I said, well, this is the AGL torque wrench. I said, well, what setting is it on? But it's the AGL torque wrench we always use, is the answer. Well, you've got to know and make sure that you've got the correct setting on the mechanical torque wrench to torque the bolt. Where the electronic one, is programmed accordingly. Eh?
Absolutely. Tony, where were the standard setters when it came to considering torque? Was it not an issue because of the traffic in the 70s and 80s, or what you know, what's going on there?
Sorry, say it again.
Well, where? I mean, if I look at the standards, I mean, they don't contain a lot of guidance in terms of torque. I believe in the UK, Cat 168 was amended to incorporate provisions for torque management, but ICAO don't appear to have a great deal on the topic.
No, you're quite right. I think the annexes to the convention, Annex 14 being the one we talk about most often, they, if you like, have the force of international law. They are standards with recommended practices. And the view of ICAO was that we are setting the standards of performance of the various elements, if you like, of the lighting system. We know what intensities, beam spreads, and so on we require. It's not our responsibility to be involved in the engineering in any way. They don't wish. Now, I know in the States, the FAA take a much more interventionist approach, and you know, you can manufacture a light provided you make it exactly to these drawings and actually use exactly the bolt that is stipulated in their standard. That hasn't been the approach in much of the world, not in this country. And if you like, there is a potential hole, if you like, in the totality of the requirements. It hasn't, as I say, it hasn't been the view of ICAO that they do any more than set performance standards of the device, whether it be an ILS or the visual aids. And in some ways, that's laudable, because if you describe everything to the last nut and bolt, and you can't change anything, then technology can never have any impact. Changes and improvements, you can't improve technology. And one could, with tongue-in-cheek, say, in fact, the tighter FAA specs in many ways have inhibited technological development. And I think that's probably very true. We found as we began to look in the electrical systems and how they're provided. So it's 1940s technology in lots of cases that's specified in the Aerodrome design manual. So there's a balance there. You do want to have innovation behind what the device actually provides in terms of a service.
Well, I think, Tony, you're quite correct, because, you know, we're now moving into a different era in terms of technology, in terms of, you know, the digital world that we're in, and the operational need to have surface movement guidance, you know, because the demand was on heavy, you know, greater density of traffic, etc., and safety. And then we have concentrated on individual light control and monitoring, but still use the 6.6 amp series circuit as the fundamental AGL system that is adopted, which any of us that have been involved with ILCMS, the individual light control and monitoring surface movement guidance, know that the 6.6 amp system is fundamentally flawed when it comes to utilizing it as a communication system rather than the power system, the power for lights. So, you know, in that respect, that innovation was rather curtailed, eh?
Yeah, well, thank you. I mean, it's very, very, very insightful, Tony. Obviously that principle that Tony described there for Annex 14, that applies across everything in ICAO, and it's very important to understand, because you know, that's the basis on which these standards have been prepared. whereas far more prescriptive under FAA guidance. But of course, with that prescription comes the requirement to do the research and also dictate how the way things are done, which, as we've heard there, obviously can constrain innovation. So a couple of tips there from our audience here, who I know are very experienced in these matters. Wayne points out that when you're installing RFID tags, check them first. I hasten to add that every TMS tag is in fact checked in the workshop. They're built to the highest standards because it's very expensive, very painful, and you'll lose the confidence of the people working on the airfield maintenance team if those tags cannot be read. One of the critical factors, just to point out, is they shouldn't be buried too deep. The standard, you know, the installation should be according to the standard provided by the manufacturer. And secondly, as Steve Hutton points out from Oman, that he recommends, and in fact we recommend as a company, tags should always be positioned on the north side of the fitting so that you know exactly where to scan them, because obviously the read range is limited to avoid confusion with other tags. Now I've got a question which is a very interesting question, because often we find this when we're going to go and test a new airfield. I've explained the stress conditions under which we find, you know, installers when we're just about to test the lights, just before it's due to get light, just before the flight to test the new runway. Paul, you've been there. The question is, what should be the performance levels required during the acceptance testing of a new AGL installation? What are the relative merits of ground-based monitoring and a flight check during acceptance testing?
So there's a couple of points in relation to that. First off, that the acceptance testing level should not be determined at the point of doing the acceptance test. The acceptance level should be specified at the beginning so that there's no argument, if you like, over what is acceptable and what is not, because the contractor is going to be quite happy for a result that's above the 50% ICAO minimum, whereas the guy who's going to have his maintenance team looking after these lights is not going to be happy at that level, and he's going to want an absolute minimum of 100%. So that really is to be determined at the beginning of the project, and it should be put into the specification so that it's very, very clear from day one. And in relation to that, when it comes to the difference between the flight check and the ground-based monitoring, they both have their own purpose, but very much with the MARMS equipment, the ground-based monitoring, we are checking that the light is performing as it's designed and giving the pilot the best possible visual cues. And we will pick up installation issues that a flight check would not pick up. We can pick up things like bases not installed correctly and slightly on the angle. We can pick up lights that are towed incorrectly and various things like that, which can all be sorted out before you have the flight check.
Yeah,
and the flight check should really be deemed to be kind of like a final thing.
Could I say something on both of those? I mean, first of all, ICAO expects that by implication, a new installation certainly should meet the requirements of Annex 14, those isocandela diagrams, 100%. That we live in a real world, and we know once they're installed, there'll be degradation. And one can't really expect practically to get 100% all the time once it's installed. But when it goes in new, it should be 100%, full stop. There shouldn't be any argument about that. It should be written into the contract. I agree very much with Paul. you should state that it should comply with Annex 14, which are minimums, if you remember. Actually, is the minimum values that are specified. That's what should be tested. As for the flight test, I can give you various horrendous stories where visual aids have been flight checked as serviceable and they clearly weren't. And one of the reasons why you need testing like MARMS does is that you cannot, for example, in any way get anywhere near knowing whether the light outputs are compliant with what's in Annex 14. The eye is a wonderful sensor, but we're not very good at absolutes. It's like saying a few people in this world are pitch perfect. They know when they hear a note exactly, but there isn't anything really equivalent with that with the eye, and you cannot, just by looking at it, know whether it's the right intensity. And that goes, for example, often done on a flight check. During the approach, the inspector will ask for the lights to be exercised at various brightness levels. And you'll see the functionality of the lights getting brighter or dimmer in 5, 6 stages, fine. But that doesn't tell you what output you're actually getting. It's useless for that. And that's where my story in this, going back to the 70s, started. An international airport in this country, which had been flight checked within the previous week as being serviceable, having outputs in the runway center line less than 10%. What you do get when you go through those 5 stages of brilliancy, you see them going up and down. They had in the past, anyway, because they were tungsten halogen, you see differences in brilliance because the color changes. That's basically how we know whether one light's brighter than another. We see the color change. Now with LEDs, that cue may even disappear to a large extent. So flight checks are pappy. Well, that's a joke, really. Again, apart from the functionality, do the lights go in the right order from out to in what they change? But in terms of where the transitions are, even if you set out carefully to fly a flight path to measure that with a stopwatch or something, it doesn't have anything like the accuracy of the systems that are provided by things like that TMS provide. And actually,
I can just, Robert, if I can just add one thing. You were mentioning earlier on that the time schedule for these activities is usually very compromised and it's very compressed at the end. One thing that is apparent is when you're doing the photometric testing for proving compliance, you need to schedule in a clean, because I've been to sites where they've still had diggers and bulldozers and trucks bringing mud and dirt onto the runway. Those lights aren't clean. They're not going to meet 100%. On the other side of the scale, I've been to places in the Middle East where it's been a brand new runway, literally in the middle of the desert with no buildings around, and sand blows in there and causes all sorts of havoc with your readings. You have to make sure your lights are spotlessly clean if you want to achieve that 100% on a new installation.
Absolutely.
And kept clean. So I've got some, I was going to cut off there, but we've got a flurry of questions coming in here. I see Keith is also volunteering to answer one, but in order, I will just say Ahsoka has pointed out, he says, with the improvement of technology, many of the airports have upgraded their systems with high performance LED lights with high cost for long lasting operation. But most of the products will not perform as their design levels of performances. Considering these conditions, would you recommend upgrading aerodromes with LED lights, Keith?
Is that for me?
Yes.
Okay. Well, Osaka, I mean, one of the elements in LEDs is when you are looking forward. Remember that when you're looking at upgrade projects on an airfield, it tends to be in line with the civil engineering side of runway resurfacing or something like that, 7 to 12 years. So if we look forward 7 to 12 years, that kind of timescale, and you're looking at whether or not you should upgrade to LED in that timescale, you have to take into consideration that tungsten halogen and the manufacturers of tungsten halogen airfield lights are gradually reducing production so that perhaps your tungsten halogen lights in the future will not be able to be serviced because of the lack of opportunity to get the respective lamps. And so number one is that really I think we've gone past the point of no return when we are going to migrate from tungsten halogen to LED. So the answer is yes, I think that is the future. You know, you will definitely need to have to go this way. But is the level of, and then you're talking about the return of investment really, is about the high cost. Then the manufacturers of the LED lights will give you an indication of what the return of investment is. But then remember, and it is an LED, and an LED as a cluster in a light fixture has a long life expectancy. However, that LED needs to have a driver, electronic driver. It's a DC component, so inside that driver package there will be a rectifier. And then if it is a light fixture that now is offering ILCMS as a smart light, for example, then there's more electronics in there. And so the element associated with the construction of an LED light fixture is there is very little workshop servicing you can actually do to it in comparison to tungsten halogen. So whilst yes, the LED itself gives you longevity, then the light fixture itself may not give you the longevity that you potentially think you might get. And so the whole element of how we operate and maintain LED fixtures is changing. It's changing. So do I recommend changing? I don't think you have a choice in a way.
But that leads on to your next, you've indicated here you wish to take live the question, what will be AGL in near future? From Kuvit.
Well, Kuvit is calling from Turkey. I know Kuvit very well.
Kuvit.
Yeah, Kuvit, I know, I mean, in Turkey, for example, in Istanbul, just recently, one of the manufacturers made an announcement that there is a new generation of lighting circuits going to be installed. And basically, if I looked at that new generation of lighting rather than the 6.6 amp system, then if I look at the need for powering the lights and the need for communicating to the lights, both for monitoring and for control, individual light control and monitoring, then if you have that need for a control, then I've already mentioned that the 6.6 amp system is fundamentally flawed in many ways when it comes to communicating across the system. Then perhaps the new generation is worth looking at, and probably have a look at the installation that has just been put on LinkedIn and publicized. Then perhaps that is the way to go. We look at control first and then power afterwards, rather than looking at power and then control.
Okay, thank you. Wayne has just added here that the standard for acceptance testing, I mean, should be specified by the consultant, but as in the tender. So there is so the contractor is fully aware. But of course, as Tony says, it should be 100% per the standard. The issue that we often face, and the reason why this does need to be specified and might not be 100%, is that in some cases only you can get new lights installed on an old circuit, and so sometimes it's very difficult to deliver 100% if you've got infrastructure that won't support it. It's never, if only life could be so simple. We've been asked here, Diwaka would like to know what kind of duct will be suitable in a new runway for inset light fitting for secondary cable, and what should be the depth of the duct? Keith, do you want that one?
Yeah, say that again.
Well, what kind of duct will be suitable for new runway for inset light fitting for secondary cable, and what should be the depth of the duct?
Ah, the ducting. Yes. Okay. Well, that will depend on where and how you're going to. Is it going to be asphalt? All right. For example, one of the elements of when we use ducting and out to the light fixture is that we would put the ducting in the sub levels so that the secondary cabling is not affected once the overlay, if we do a runway resurfacing, so the top level comes off in a runway resurfacing, so we would have our ducting below that in the subtray, and then that will depend on also whether or not we've got side entry or bottom entry into the base unit for the light fixture. So there are different methods of way we would do that. If you'd like to contact us separately, we can go through the various options. This is, too long a subject in many ways to discuss over a webinar.
Right. Well, no, the last question I'll put in here. This is kind of a comment come question. I'd like each of you to have a final statement on this. Ahsoka has said, according to ICAO, 50% is the minimum. Can we find? Can we just point out to Ahsoka where in the standard the required level of maintenance is 70%, which it is. We will point that out if any of you can remember the particular reference.
I can indeed. It's ICAO document 9137, the Airport Services Manual Part 9, Section 2.6.9.
Well done, Paul. So there you are, Ahsoka. If you didn't note that down, we'll put it in our written answers on the website. But Ahsoka says rather concerningly,
Robert, is also is the fact that, whilst the guidance there at 70%, he's also mentioned 90%, but then that's a local decision. Anything
yes.
above the minimum is a local decision.
Yeah, so in ICAO it states 70%. It recommends 70%, but I know several airports that use a figure that is higher for maintenance.
Yes.
So Ahsoka then says, and rather this is a concern because I've heard this myself. Since the manufacturer and contractors always argue with us, their products always comply with ICAO because the performance is just above 50%. So same subject we've discussed. It needs to be specified. Is he talking installation after installation and commissioning? And the fact is that it needs to be specified in the acceptance criteria for the project, in the project definition stage, and as Tony rightly says, in a brand new installation, that is cabling, primary cabling, connectors, isolating transformers, secondary cabling, connectors, light fixture, correctly installed, in accordance with the requirements, according to the pavement, etc., then the criteria by ICAO is defined in Annex 14 by the isocandela diagram, and that is the minimum requirement of 100%. Right. So we recommend that all new lights are tested on before they're installed on the runway to ensure they meet the required standard. Bear in mind that the condition of the pavement and the electronics also have a bearing on the result of the in field. So, but if you test them in the workshop on a photo bench, for example, they should always meet the standard in those conditions, because obviously we have a proper power supply and we have accurate measurement equipment to test that. Beyond that, really, it's a matter for between you and your supplier. You know, of course, nobody is perfect. There can always be issues, but you need to take them up with your supplier.
Oh, and your installation contractor.
Yes.
Remember the factor, you know, whilst the light fixture is designed by the manufacturer normally to exceed the minimum requirements of ICAO, and that's for manufacturing, from component manufacturing purposes and for installation purposes. Though if the light fixture, as you say, Robert, the light fixture itself then meets the requirement of 100% or above, then that light fixture is serviceable. If when you've installed it in the field that it is below 100%, there is an installation or a defect in components.
Yes. So Keith, I'm afraid, Keith, Tony, sorry I'm taking up so much of your afternoon. We've actually gone 3/4 of an hour over time, which is not good time management. But I'd like to thank you all for your participation today. Fantastically intuitive as ever, and I hope the audience, and thank you for so many that have stayed with us for such a long time after we were due to finish. Thank you for your participation. It makes it all worthwhile for us. I'd just like to say, finally sign off with the fact that signs, that the ICAO Annex 14 says signs shall be provided to convey mandatory instruction, information on a specific location or destination on a movement area, or to provide other information to meet the requirements in the standards. And that will be the topic for next week, is how they achieve that, how they're installed, what the standards are, and how to maintain them, and why they're so important. So
and to demonstrate compliance, yes?
I beg your pardon?
And to demonstrate compliance.
And to demonstrate compliance. Thank you, Keith. So thank you very much, everybody. And I look forward to seeing you all at the same time next week on the topic of signs. Thank you, panel, and good afternoon. Goodbye.
Bye.
See you at 4 o'clock.
Bye. Yes.